Good afternoon. Today's video is calculating the slope of a line. We're just going to review some of our requirements for performing this activity. First off, you're going to need a title. The title at the top, underline it. The title should be in pen. You're then going to have to label the x-axis with the appropriate units and the y-axis with units. The axes should also be done in pen. Next, you're going to have to choose an appropriate scale. And the scale you choose will be based on the data. You want a scale that's going to produce a line that's nicely stretched out. You don't want a line that gets bunched up along the x-axis or too low along the y-axis. You want to get a line that really spreads out nicely. And so your scale you choose will be by trial and error. You might want to do the first couple in pencil just to make sure it works nicely, and then with scale. And you notice I'm doing these differently to show that they don't have to be the same. And then you label your origin. Now, the data points must be in pencil. I want them in pencil so you can erase them. And I'll use blue ink. So we got 1 and 2 here, and then here the next point. I'm kind of drawing these all over the place, and I'll make a point of why I'm doing that later. So here are our data points. What you're going to be doing, or trying to do, is draw what we call a line of best fit. So what line can you put through these points, or be between the most number of points, but not actually go through any? And that's the line I just chose. I just eyeballed that. As you can see, there are some points, and I'll use red, like this one, which are kind of way off the line, and that, that we could call an outlier. And it kind of indicates why you don't want to just connect the dots. Because if you were to try to connect these points, you'd have a slope going up, a line going up in this direction, which would have a much different slope than, say, if you just connected these points. And so what these different points indicate is that there's been some error in your measurement. And so none of them are absolutely perfect. The precision is not all that great, and you wouldn't want to use any one of these points for calculation of your slope, because your slope is going to give you an idea of what the actual value is. And so for calculating slope, you choose 2 points on the line. Extrapolate down, across, the values, down, and across. And the slope simply be the rise over the run, which will equal to change in y divided by the change in x, which is equal to y2 minus y1 over x2 minus x1. Perhaps I should say just a word or two about units. Not all slopes have units, but some do. So density is the mass divided by the volume, but there are no units. However, resistance, which equals voltage divided by current, has the units of ohms. And so just be careful. It's not like math. Sometimes we do have units, sometimes we don't. And that's all.